Hello students and welcome back. In this video, we'll be creating a solution of known molarity. This is very similar to the last lab that we did converting concentration units. So it really is basically the same thing. But we'll go ahead and give it a run through. Let's get started. First, you'll need to click on your creating a solution of known molarity link, which will take you to the correct setup in the lab. The next step is to click on the balance to zoom in. You can go ahead and click tear, but you really don't need to because we're going to put a piece of waypaper on the balance and click tear. That will remove the mass of the waypaper from our calculations. Next, we'll weigh out 1 gram of sodium bicarbonate, which is already on the bench. So remove the cap and we're going to weigh approximately 1 gram. So we'll need to click on the 1 gram spoon and drag it to the weigh paper. You can see that you have almost 1 gram here, 0.9618 grams, and you'll need to record that um, in your lab book because you'll need to record that on your lab worksheet. And I'm just going to put a note in my notepad, 0.9618 grams of NaHCO3, because at this time I can't access my lab book. Okay, so we're done with that, except we need to put this into the beaker. All right, and we can now zoom out. We have our sodium bicarbonate in the beaker. Okay, so next we're going to add, we're going to bring the beaker forward, and we need to add 10 milliliters of water to the beaker. So let's find the 10 milliliter graduated cylinder right here. Pull it under the tap until it is full. Now, you never would use regular tap water. What you're seeing here is 2 different types of water in the lab. One of them is tap water and the other is deionized water. You'll always want to use deionized water if you're in the actual lab. And in fact, in our labs at JSU, we have carboys of double deionized water, which is very, very pure, nanopure water. Okay, so we need to add that 10 milliliter graduated cylinder full of water to the beaker. And what we want to do is make a 25 milliliter solution. So we need to pour the solution into the a 50 milliliter solution. We need to pour the solution into the 50 milliliter graduated cylinder. Normally you would use a volumetric flask for that, but this simulation doesn't have volumetric flasks because volumetric flasks are more accurate. So go ahead and pull that to the 50 milliliter graduated cylinder and dump it in. Next, we'll simply pull the 50 milliliter graduated cylinder under the tap to finish filling it, and it will snap back when it's done. And now we'll record the volume of the solution, which is 50.00 milliliters, which I'll record in my little notebook over here that I have on the side. And then next we'll need to calculate the moles of sodium bicarbonate and the molarity of the solution. So let's go ahead and add that to our lab book. Let's say, so first of all, let's take a picture of the lab. Click on the Save Lab Image so we can get that into our lab notebook. And that should show up as today's date. Okay, it did. And next we'll put 0.9618 grams of NaHCO3 and 50.00 milliliters of solution. And that's the information that we need to perform our calculations. Next, we'll get started on our calculations. You see here that we have, let's go ahead and draw this, 0.9618 grams of NaHCO3 and 50.00 milliliters of solution. So the first question asks us to calculate the moles of NaHCO3. In order to do that, we need to first calculate the molecular weight of sodium bicarbonate. So sodium is 22.990. Then we have hydrogen, carbon, and 3 oxygens. Hydrogen is 1.008, carbon is 12.011, and oxygen is 15.999. So first we have, so the molecular weight, I'll say MWT, is equal to 1 times sodium plus 1 times hydrogen, because we have 1 hydrogen, plus 1 times carbon plus 3 times oxygen. Okay, so that's equal to 1 times 22.990 plus 1 times 1.008 for hydrogen plus 1 times 12.011 for carbon plus 3 times 15.999 for oxygen. All right, so now we just need to calculate that. And I got 84.006. So that is the molecular weight, and our units are grams per mole. So the question asks us to calculate the moles of sodium bicarbonate. So we use our molecular weight as a conversion factor. We have 0.9618 grams of sodium bicarbonate. 0.9618 grams of NaHCO3. Now we need to determine how many moles are in our sample. So the molecular weight is 84.006 grams per mole. All right, so we divide 0.9618 by 84.006, and we get 0.011449 1822 moles. We have 4 sig figs here due to the limitation with our graduated cylinder having 2 decimal places, and so that gives us 1, 2, 3, 4. So we'll draw a line under our last significant figure. So we could go ahead and round, but we'll just keep maybe one significant figure beyond. So we'll say 0.011449 and I'm going to draw a line under the 4 here. Next, we're asked to calculate the molarity of the solution. And molarity is moles of solute. It's important to remember these definitions per liters of solution. All right, and so that's equal to 0.011449 moles of NaHCO3 per, and we had 50 milliliters. Remember, 50 milliliters. We're going to divide by 1,000 to convert to liters, or we can move the decimal point to the left 3 spaces. That gives us 0.05000 liters. So when we divide 0.011449 by 0.05, we get 0.229 0.2290 molar. So that's how we perform the calculations for our lab.